Hello, everybody. All right, my job is to wake you up after lunch so you're very attentive and learn lots of stuff from the presenters. My name is Eric Hellman. I am the Executive Director of Project Gutenberg. It's a new job for me. So it's my first time here is doing that. All right, a little exercise to wake you all up. We are in the town of the best sports mascots in the world, but there's a controversy as to which one is better. So I'm going to give you the choice. Philly Fanatic, let's hear it for Philly Fanatic. Really? How about Gritty? All right, okay. I declare Gritty to be the winner at Code4Lib. We will invite him to be a speaker the next time we are here. All right. Afternoon session. We have breakout sessions after some talks, and a poster session coming up this afternoon. I guess those are already out there, so you can go and look. I have to display this page and scroll to the appropriate section. How do I do that? What? I know that. So, I have to figure out where that page is. Should be where? Help, 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 help. All right, he's training for the role of Gritty. Yeah. All right, anyway, the schedule. So I have to announce the community support volunteers for this afternoon. So until 3, the support volunteers are Anne-Marie Mesco and Louise O'Shea. And but there's a cutover at 3 o'clock. You'll be in the breakout sessions, but magically the support volunteers will change into Natasha Allen and Sharon Clapp. So let's hear it for the support volunteers. The online community support volunteer until 3 is Andromeda Yelton. That Andromeda on the socials. And after 3, it's Caleb Dervin. Yeah. So since there's overlap for the breakout sessions, if you have something that you want a community support volunteer for, you can go to any of them. Okay. And the community support volunteers are supposed to be in the back with zebra striped lanyards. There they are. Hi. Okay. Giveaway time. Really? Oh, I get to do giveaways. Today's giveaway is a 1-year Rosenverse Gold membership, giving one lucky winner full access to Rosenfeld Media's complete digital book catalog, conference videos, and premium community benefits. We'll follow up with the winner directly on Slack with all the details. So do I get a spinny somewhere? Oh, there's a spinny on my computer. On this one, right? Oh, where's my spinny? Oh, I didn't read this. It was a late edition. I would have to know. All right. What? You know? All right. All right. Let's get off my lawn. Let's hear it for Matt. Okay. Yeah. Anyway, so for all conference attendees, Rosenfeld Media is providing a 50% off discount code for their gold tier subscription, which Chris will post shortly in the Code4Lib Slack channel. Is Chris here? Chris here? Someone on the Slack channel will post the code in the Slack channel. So I'm going to spin the magic wheel. All right. Christy Bailey Tomachek. Congratulations, you can collect your prize wherever the prizes are to be found. All right, talks. It's time for talks. Okay. All right, the first talk is, this is a talk I voted for, in fact. Yeah, but what's down here? I have to find it. It's Birkin James Diana with Happy Days. Hi. Happy Days and Happy Patrons, The Wonders of UV. I'm super excited about this because I'm a fan of that XKCD comic about Python environments.
Just help me get it open since I'm...
Oh, yeah, you want to... Okay, you have the PDF thing, right?
And it's in there, it's already loaded, and it's named, it starts with Birkin.
I know. I saw it. What? Did I do the wrong thing?
Maybe sort by name? There it is down there, maybe. Yes.
I did it without you, ha ha ha. All right. So,
You can give him that one.
which one do you want?
I'm going to use this one. Testing. Ooh, testing.
All right.
Okay. All righty. Okay, let me just make sure. I did not do this yet. Full screen mode. Okay. Okay, I'm going to launch in. Hi, I'm Birkin Diana, a developer for the Brown University Library, and this talk is about a little open source tool I've come to love, UV. So what is UV? UV does a lot of things. Yes, I'm going to be good. I'm going to really try to be good about this. UV does a lot of things, but I found it most useful to think of it as a Python package manager and more broadly as a tool for managing Python virtual environments. And I know this is Code4Lib, but just so we're all on the same page, to clarify two terms. Python package. You can think of a Python package as a bundle of code that does something. Like make web requests or work with XML. And Python comes with lots of useful bundles of code or packages or modules built in. So sometimes you don't need to install anything beyond Python. But there are lots of really useful third-party Python packages that can be installed. And virtual environment. Project A from 2 years ago might have been built with Python 3.8 using a third-party XML package version ABC. And Project B that you're working on now might be using Python 3.12 using the same third-party XML package but version XYZ. And virtual environments are a way to isolate these Python package environments so they don't conflict with one another. Okay, in this talk, I'll share two main things. First, how our dev team started using UV for our development projects and how we now use it. And second, how UV offers ways we, or colleagues, can share code with end users who are interested in working with code-based tools but are not that interested in nuances of installations in virtual environments and package environments, package management. Okay, so the standard ubiquitous way folk work with Python packages and virtual environments has been via the tool pip. And UV has an entire pip compatibility mode so that practically everything you've done with pip you can do in almost the exact same way via UV. So if you have a virtual environment activated, instead of using the standard pip install pymark, you could use UV pip install pymark. And if you have a requirements.txt file listing the packages your project needs, you can run a UV command very similar to the standard pip install R path to that requirements file that will populate your activated virtual environment in nearly the same way. And because we were so comfortable with pip, that's how we started using UV. And yes, UV's faster, and yes, some of the ways UV does things under the hood are more elegant, but it wasn't a tremendous savings. If you're cautious and conservative, this will help you feel more comfortable about using UV, but my recommendation, don't do this, because the alternative is so fantastic. Okay, the way we now use UV centers on a file named pyproject.toml, and this is not a UV specific thing, it's a standard Python specification. Here's part of one of our typical pyproject.toml files. For time, I'm only pointing out two things in this file. Requires Python. You can't really see the shading, but it's line 6 there. You might not be able to see line 6. Requires Python where a Python version or version range is specified, and dependencies. And if you use a standard pip requirements file, the dependencies section will look very familiar. Like with the requirements file, you don't have to specify version numbers, and if you do, there are different syntax options. Okay, let's say I CD into this project. And let's say I set up this project a couple of days ago, but haven't done anything regarding a virtual environment. I see the runtest.py file, and I want to run that. I often start work on a project this way. To paraphrase a line from A Muppet Christmas Carol, I must ask you to remember that I do not have a virtual environment. That one thing you must remember, or nothing that follows will seem wondrous. Okay, I try to run the tests, and they run. And remember all those dependencies. The kind of awesome significance of this, you think about your code and what you want to do, and the virtual environment stuff is automatically taken care of. Here's what UV is doing under the hood. It updates or creates a uv.lock file with the pyproject.toml dependencies and subdependencies. And this is like the file that pip compile creates, but better. It specifies a Python version or version range and is more universal across architectures. It then downloads a valid version of Python if necessary, and downloads any dependencies if necessary. And all these version downloads are stored and will not need to be downloaded again. It sets up a venv environment with a valid version of Python, and it then syncs to that venv environment all the dependencies listed in the uv.lock file. And it does all that in the blink of an eye. And then UV runs that runtests.py file in the context of the venv's virtual environment. Here is a part of our code deployment script. The highlights: we cd to the project directory, we run a uv sync command, and this one line fully updates the virtual environment from the uv.lock file super fast. What this means is that if you're deploying a branch using this approach to experiment with a new version of Python or a new version of Django or a new version of some other package, or going back to the main branch afterwards, you don't have to think at all about managing the virtual environment. Your deploy process is exactly the same as a code-only deploy. Your code changes to the pyproject.toml file, auto-flow into an updated active virtual environment seamlessly and very quickly. Okay. What I've shared so far has been about how UV can be really useful for development, and I love it for that. The second half of this talk is about features UV offers that simplify working with code for end users and for our colleagues that work with end users. The problem being addressed: many of us have had the experience of running a workshop for users on something like how to access APIs or use natural language processing tools, only to get bogged down in the setup process, helping users install a certain version of Python and then necessary dependencies in a virtual environment. That can be dispiriting for end users. Now, sometimes a Jupyter Notebook or a Google Colab setup can minimize this, but UV can also be very useful for this too. So everything that follows does require end users to install UV. Most installation instructions are just one-liners, but it is a requirement. So imagine you are, oh, I forgot that slide. Okay, so this is the context of the things where this is useful for end users. All kinds of things. So imagine you're running a workshop for folk wanting to learn about APIs and how to access them. You want to show them useful code to access the API, and you want them to be able to run this on their own computer so that they can more easily experiment during and after the workshop. Okay. You give your users this sample code to access an API. Then you ask them to cd to the directory where that file is and then run it. And they run it and it works. And you point out how the code accessed the URL and then parsed the JSON response and printed the result. You focused on API concepts and code. What you haven't done is spend any time with your users on setup and installation. No time on installing Python or a virtual environment or dependencies. Not because this is hidden in a way that they'll have to figure out later, but because this is the way UV works. The magic is in that inline script metadata at the top. And like the PyProject.toml file mentioned previously, this is not a UV-specific feature, but an official Python specification. Under the hood, UV is doing something very similar to what was shown before. Downloads the version of Python if it's not already available, figures out the dependencies and sub-dependencies needed, downloads dependencies that aren't already available. Again, version dependencies are stored for reuse. It sets up a virtual environment with a valid version of Python and those dependencies, and it does all this invisibly to the user with caching, so subsequent VENV preparation is blazingly fast. And finally, it runs that API script in the context of that virtual environment. One minor aside, what if your script needs a secret API key? You could, of course, pass that into the script as a command line option, but UV offers a special option perfect for this. You can tell your workshop users to create a file named like secretstuff.txt and put API key equals whatever, and then run the script like before with that UV-env file path. And UV will make envars available from that file, scoped just for that environment. So here's one question. If both PyProject.toml and inline script metadata can both manage the virtual environment, which to use and when? A brief answer, use PyProject.toml for projects and inline script metadata for single file scripts. There are gray areas. PyProject.toml offers many more features, but that is a workable rule. Okay, as we've seen, inline script metadata is this key to how useful UV can be for end users. But for colleagues working with end users, UV also offers a feature that can be super useful for sharing scripts that end users can run easily from their own computers. And that feature is that UV can run on your computer remote code. Obviously, this requires re-stressing the broader point to be very careful about running untrusted code. But I'll show you a few examples about how this could be really useful. First, UV can directly run code in gists, providing great opportunities to share code with end users. But maybe you don't want to share with your workshop users lots of individual gist URLs where the URL doesn't convey meaning. Wouldn't it be nice to group useful scripts together in a GitHub repo and share links to those scripts? Well, you can do that, but it's not ideal. Here's an example from a little utilities repo of mine. This particular utility script just outputs random characters in a way that I like. The URL does contain more meaning, but you have to use a raw GitHub URL, and it can't be described as friendly. The ideal would be a way to bundle together a bunch of useful scripts in a repo, but with a friendly interface and friendly URLs. And a combination of UV and GitHub pages offers just this. So we have a small GitHub repo of tools for end users for working with the Brown Digital Repository public APIs. But we don't advertise that repo URL, but instead refer folk to a nicer website URL. And this is just a part of that much friendlier website, which is auto-created from the repo via just 3 one-time steps. And this is GitHub Pages stuff. You create an index.md markdown file, which automatically becomes the landing page HTML. You change one setting, you click save, and in a few minutes, reloading the page will show the URL to your new website, auto-built and auto-updated right from the repo. Your colleagues can give that link to workshop users, and that landing page is easily updatable by your team or your colleagues via the index.md file. And in that index.md file, Markdown, you can mix explanatory material with code and usage instructions. And those usage instructions can contain friendly URL UV commands like the one shown here, BDR API tools /calc collection size.py. This script takes a collection PID argument and calculates the size of all the items in the given Brown digital repository collection. Yet again, the focus is on concepts and code and functionality, not on environment particulars. Okay, to sum up, I love UV for two main reasons. For devs, it makes deploys affecting the virtual environment no different than code deploys, which greatly simplifies experimentation and package upgrades and rollbacks. And second, it can really simplify the process of sharing code with end users. We can work with colleagues who do trainings to come up with scripts that end users can bookmark and experiment with without discouraging setup friction. There's a lot more that UV does, but these are the highlights for me. So I hope you all enjoy using it for your own dev projects, and I hope you enjoy sharing it with colleagues who do workshops for its end user features. Please do feel free to ping me with any questions. Thanks.
Yeah. Hang around, okay. So we do have he finished a little bit early, so we have time for one question. Anyone? This is a great talk. I will make use of it.
Yeah, it's fun. It is fun.
Everybody, it's a good talk. Nobody has any questions. That's great. Okay, thank you. Thank you very much. All right. For our next talk, do you want to find your thing in here? Let's have to put this away. See, that's the end of the last talk, see? You want to, figure out how to... Oh, nice. Beautiful. So it should be in here. Oh,
There we
got
go.
it? All right. Doing more with SSH. And Corey Halpin is going to do a talk on this.
It's going to be secrets.
Oh boy, oh boy, oh boy, oh boy.
So there are a pile of things I've learned about using SSH that I desperately wish I had heard about years before I learned them. Here are some of my favorites. We're going to start off with an overview of the cryptographic building blocks that SSH uses, talk about some config tweaks we can make on the server side for tighter security, hit a few quality of life improvements that you can make on the client side to make using it easier that way, touch on a few fun network tricks that you can do with SSH, and then round it out with a little menu of companion tools that go well with SSH. The cryptographic building blocks that are used for every SSH connection. You start off with the key exchange, which is a mechanism for establishing a shared secret over an insecure channel. Then you use symmetric cryptography, which are codes where both sides of the conversation use the same key for encrypting and decrypting the data. You can use asymmetric or public key cryptography, which uses key pairs, a public portion that is widely distributed and a private portion that only the owner should have. These two parts of the key perform inverse operations. Something that's encoded with the public key can only be decoded with the private key and vice versa. Within the context of SSH, they use this to establish identity. If you can prove you have the private key, then you must be its owner. And lastly, message authentication codes, which ensure that the data in transit has not been tampered with. At the beginning of an SSH connection, algorithms for all four of these different mechanisms are negotiated between the client and server, and then a conversation between them ensues. There are a number of guides out there for tightening up SSH security. Here are two that I like. Those links are clickable in the online version of the slides, so we don't have to type them in here. Mozilla's guidelines are great, Secure Shell as well. They go in some detail about what they consider to be weaker cryptography, and then at the end provide config directives to only enable the strongest things. But they're using a whitelist about it, which is not ideal because it means anything newer and still stronger than what was available when the guide was published is implicitly excluded. So instead, if you use these kinds of config directives, it will exclude the stuff that the guides don't like while still allowing newer things, stronger things, to be employed. The next thing these guides recommend is limiting what users are even allowed to access your SSH server. With an allow groups directive like that first one there, that limits it to only people who are in the SSH group can log in. They also suggest disabling password authentication and only allowing key-based authentication. Passwords can be brute forced. Keys, you need to steal them. You may need to have some exceptions to that. I've added one at the bottom here with a match directive that allows passwords from trusted networks and requires keys otherwise. There are also other kinds of match directives you can use to do things that aren't just IP ranges. Okay, on to the quality of life improvements on the client. Connection multiplexing is probably my favorite one of these. It's a way to make a single connection to a given server, and then every time you SSH to that server from your computer, it shares that connection. On that first connection, you need to authenticate. Second and subsequent connections, you don't need to enter a password or provide a key or anything. In order to set that up, you put in your SSH config control master auto, which enables the connection multiplexing, provide a control path, which tells everybody how to find each other for these conversations, and then that last directive, control persist 30, says, keep this connection going in the background for 30 seconds after the last foreground connection drops, so that if I connect again, you'll still reuse that. I had mentioned key-based authentication. That's something users can set up by creating a public-private key pair using SSH keygen. I generally go with one key per computer, but different organizations have different requirements. You add a public key by adding it to your authorized key file in your .ssh folder. There's also a little helper program, SSH copy ID, that automates that process. A lot of people will make passwordless keys so that you can just log in if you have the private key and you need no other information. That's not ideal because you are then trusting the security of your file system to be all of your security. If someone steals your private key, then they can impersonate you. If instead you put a password on the key, they need to both steal your key and learn your password in order to be able to log into your servers. But I don't want to enter a password every time I use the key, you think to yourself. This is what SSH Agent is for. It's a little helper program. It keeps an unlocked copy of the key in memory and then just reuses it each time you need it. Most desktop environments automatically start an agent already for you. If you're on a Mac, there's a built-in agent that's already running. You can add all of your available keys with SSH add at a terminal, see the current ones with add-l, and delete them all with add-d. Once the key is unlocked, you just don't need to enter the password a second time, so this is a I got into the office SSH add and I'm off to the races situation. Agent forwarding is an additional layer of magic that you can put on top of this. It will take requests made on remote machines and forward them back to the agent running on your desktop. The way that looks, SSH add on your desktop when you first sign in, then SSH-cap A into a development machine. That authenticates with the unlocked key in your agent. But then the magic happens when you SSH onto a production machine. It also uses the unlocked key that is on your desktop to log into the production machine, not just for SSH, but also if you're SCPing things. And in the config, you can add it with those sort of directives at the end there. Jump hosts allow you to leapfrog through SSH servers to get to a final destination. -J gateway like this will first hit gateway and then forward on to to the development machine. You can set that up in your config, and for example, to do it for every host in a given domain, that first directive says gateway is always a direct connection, but anything else hop through the gateway, and then that lets you be nice to your firewall settings so that most of your machines are not publicly accessible. Local port forwarding allows you to put a port on localhost connected through your SSH server off to somewhere else. In this example here for MySQL, port 3306, the MySQL port on localhost, will be forwarded to a database server through a development server. If you start your morning this way, you can use the MySQL command line client on your desktop and point it at localhost 3306 to talk to your database. You can use MySQL dump. You can use any of those nice graphical database clients on your desktop, and it'll still talk to your survey as if they were on the same network, and config directives at the end for doing that automatically every time. Dynamic port forwarding takes that even a step further. If you use -D 1080, it creates a SOCKS 5 proxy listening on localhost port 1080, and anything coming into that gets forwarded out through your SSH server onto the network. I use this instead of our campus VPN because it is an easier way to get to library resources. All right, companion tools. Terminal multiplexers like tmux and Screen give you a way to disconnect and reconnect sessions. It can be really nice for long-running jobs or things you just don't want to die when your network drops out. tmux is my favorite of those. There's a program called Mosh, the mobile shell. It bootstraps connections over SSH, but then moves to its own custom protocol that is optimized to gracefully handle disconnecting, reconnecting, packet loss, slow connections, changing IPs, and provide much better interactive latency. The cons are you need some open UDP ports on the server, and it can't do agent forwarding. Personally, I'll use SSH across a hallway or a campus and Mosh across a city, and I'm not sure if it's just the placebo effect, but it does seem much nicer to me. A lot of the major editors have integrations for SSH where if you just know the special syntax for talking about a file, it will transparently download it, edit it with your user interface and your latency of the local machine, and then when you save, it just re-uploads it. Emacs and NeoVim both support it. In theory, there are other editors, I don't know. And then lastly, there's a little program called Shuttle, which calls itself a transparent proxy meeting a VPN over SSH. You need root access on your local machine to use it, but no other special configuration. It just transparently forwards everything over the server. If that -D thing is too much and you don't want to configure a SOCKS proxy, you can use this and it'll just all go automatically. I had mentioned in the abstract for the talk the SSH tunnel feature. It can do a lot of the same things that Shuttle does, but it requires you to turn on a non-standard feature in your SSH config, and you need to do the networking setup manually, and you often need root on both ends. I actually cut that slide when I realized I haven't used that in 5 years. Every time I want that, I just reach for Shuttle because it does the setup for me automatically. And with that, thank you.
So we have another talk that is right on time, and we do have a time for 1 or 2 questions. Anyone? 14 seconds? Well, we started a little bit early. Anyone? No, another perfectly clear talk that I certainly learned so much from.
Thank you.
I do not know all that stuff. Okay, next we have not just the data, holistic frameworks for AI use, and this is Summer Sheltonhelm. You have to find on there.
Oh, I got it,
Yeah,
don't
you
worry.
got that? You got that? Phew. These guys are good.
All right. Hello. My name is Summer Sheltonhelm. I am the Digital Access Services Librarian at Yale University's Beinecke Rare Book and Manuscript Library. Throughout parts of the talk, I switched between talking about AI more broadly and talking more specifically using terms such as generative AI. This is an attempt to reflect terminology used in sources consulted. Over the last few years, many institutions, including universities and libraries, have promoted the use of AI. Libraries are encouraged to consider AI for cataloging new materials or meeting digital accessibility requirements. Guidelines for staff use often center data protection and privacy, bias, and hallucinations. While these issues are concerning, they're just part of what we should be concerned about. When we consider AI for our work, we should ask, What knowledge or skills are lost when we use AI to perform our work and support the work of others? How does AI usage, in what ways are we undermining the capacity to engage in scholarship and conversations about cultural heritage? How does AI usage contradict our institutional missions and values? What legacy are we leaving for future library and archives workers, stewards, and patrons? Studies have found that while usage of AI and generative AI can improve one's efficiency and confidence in their work, it is in exchange for decreased creativity and critical thinking and can lead to AI overdependency. If we rely on AI to generate metadata, how do we critically evaluate that metadata? If we have not experienced the creating, will we lose the ability to identify and rectify harmful language? If we have not adequately reviewed the materials, how could we know the description is accurate? And if usage can lead to overdependence, what happens when the cost of the generative AI tools used by our institutions increases? Will we have to bear these costs to accomplish work at the speed now expected? Or will costs become so high that tools are only available to the privileged few, exacerbating the gap between institutions with more or less financial resources? And I also think about bearing witness. Todd Presner, in Ethics of the Algorithm, Digital Humanities, and the Holocaust Memory, asks, how can we develop an ethics of witnessing in a world in which our temporal relationship to the voices of the dead is becoming more and more distant, but our ability to call up vast amounts of information from the digital archive is becoming more and more instantaneous? Caswell and Seifer describe archivists entering relationships of care with the record creator, and the importance of considering creators when making decisions about description or access. If we extend this to AI, would the creator want their experience flattened by an algorithm? And what knowledge is lost in the flattening? In addition to knowledge concerns are those of climate change, changes to temperature and precipitation, rising sea levels, extreme weather events. These will all affect our ability to care for collections. If we are reducing environmental impacts with digital preservation or climate control within physical spaces, we must also consider the overall impact of AI. But calculating the true cost is incredibly challenging. The US Department of Energy's 2024 report on US data center energy use finds that data centers consumed about 4.4% of total US electricity in 2023 and are expected to consume approximately 6.7 to 12% of total US electricity by 2028. Data centers powered by fossil fuels contribute to pollution. Water resources are used for cooling servers and for generating power. And as Bardwaj, Alexander, and Becker remind us, AI advancements require rising electricity and water consumption. As for growing emissions, companies have made future promises only to renege, postpone, or walk back on them. Energy use for task completion varies depending on the task and model. Classification tasks use less emissions, while generative tasks can average more than 10 times the energy for the same number of inferences. And image-related tasks have a greater impact than text-only ones. Given this information, what projects should we prioritize at our institutions? Scholarship is concerned not only with preserving collections, but also us as people. As when asked in 2019's Dying Well in the Anthropocene, if there will be no one to remember what was, then what will have been the purpose of memory work? Let's talk about some values. I looked at the publicly available mission, vision, value statements, and strategic directions for the 8 institutions making up the US Ivy League system in their libraries. All had language about preserving cultural history for the future, and at least 2 called out the planet and or the climate as a point of concern. Many include statements about being global citizens and a sense of responsibility for each other and the broader world. However, many of the generative AI tools available for use at institution include content detection features that were built using the labor of underpaid workers in the global south who were subjected to incredibly harmful content without proper support. OpenAI outsourced content labeling tasks to a firm that employed workers in Kenya to label text describing self-harm, sexual abuse, and other types of harmful content, all for about $1.32 to $2 per hour take home. Workers in politically fraught regions such as Venezuela were targeted for contract labor due to the availability of highly educated workers with internet connections who were desperate enough to work for incredibly low wages. There is scholarship around the trauma archival workers who deal with harmful material experience and the ways that they should be supported. Institutions have also implemented content warnings on harmful materials. If archival workers and patrons are entitled to care, shouldn't the individuals who are traumatized to create our tools also deserve our consideration? If an institution's mission and/or values include being a responsible global citizen, we should ask ourselves, at what point does our responsibility start and stop? By using these tools or advocating for their use, are we endorsing this treatment of workers? Do we decide that the benefits to society as a whole outweigh the suffering inflicted upon the few? In terms of legacy, the SAA's core values of archivists include responsible stewardship, social responsibility, and sustainability. The ACRL's Research Library's Guiding Principles for Artificial Intelligence speaks of championing openness and transparency in algorithms, training data, and methodologies used to create AI technologies that we license. Does this transparency extend to requiring emission usage to be revealed or clarifying the role of workers labeling harmful content? What do our choices about AI usage teach to students and new professionals about the importance of and our commitments to these values? Given all this, what should we consider when we consider AI use? Agency. We should claim agency over whether we want to participate in AI usage. The ACRL's AI competencies for academic library workers states that we should retain the ability to critically assess and choose whether to adopt specific AI technologies based on ethical considerations, performance criteria, institutional context, and alignment with our profession's values. I encourage you to be the advocate for ethics at your institutions, especially if you have the positionality to do so. We could consider alternative methods and tools for our work. Consider some alternatives. Can our use case be accomplished in a different way? Ruth Tillman talks about this in their blog posts. My coworkers don't want AI, they want macros. This discusses the use cases expressed by vendors for AI components of systems and how they differed from what her colleagues actually needed. Are there less impactful tools that we can use to solve the same problem? We should incorporate other ways of doing and thinking. Learning about different perspectives on AI, as expressed in indigenous protocol and artificial intelligence, if we insist on thinking about these systems only through a Western techno-utilitarian lens, we will not fully grasp what they are and could be. Good places to start include the position paper, Indigenous Protocol and Artificial Intelligence, Feminist Data Ethics of Care Framework for Machine Learning, and the UNESCO recommendation on the ethics of artificial intelligence. We should also include and listen to a variety of voices in AI conversations. Including a variety of voices can help ensure that a variety of ethical issues are being interrogated. Listen to your colleagues and trust in their expertise and knowledge of their own profession and collections. But don't make them the only ones responsible for doing the heavy lifting of ethical investigations. The Feminist Data Ethics of Care warns about traditionally marginalized workers undertaking a disproportionate amount of feminist data ethics of care work, and that the key to widespread adoption is the explicit and equitable assignment of responsibilities to all stakeholders. And Mannheimer et al. States that ideally, ethics would be operationalized as an integral part of the how-to process in case studies. I'm about out of time, so if anything, also consult resources like Foundation Model Transparency Index, the Viewfinder Toolkit, advocate for vendors with transparency and the ability to opt out, divulge usage, and prioritize lower impact models. Yeah, let's keep talking about it. The end. Thank you.
So the next talk is on Zoom. So I will pull that up. If someone has a question for Summer or maybe an answer to one of her questions, speak up and I will get the next thing going. Anyone? Oh, everyone's tired. Okay, thank you, Summer. Oh, we had this up. I'm gonna find the.
I win.
Here,
Yeah.
I got
The next.
I got the thing. I got the thing.
Right.
There we go. Let's see, who wins a Zoom? Nobody. Congratulations.
We're close. We're close.
I'm getting
It's
there.
off there.
Yeah, I know.
Farther.
Which, this one?
No,
what,
no,
what time are we? Who just went?
You have to go down. You have to go down.
This scrolls backwards. No,
It is.
well,
It's
there it
right
is.
there. Right, that's it, that one.
Okay.
All right. And it's supposed to magically start with Esme. Yes? And this is, sometimes it's okay, it's getting started in 3D for the web. Sometimes it's okay to have 200 bugs in your code. It's always the 201st one that gets you.
It's clickbait.
Oh, Lee, you're there. We
I'm
see
here.
you. And we can hear you.
Yes, sir.
Thank you. You can start.
I can start. Okay, great. 1 second here. All right. My name is Lee Hunter. I write software for the Hokey Bird, and I'd like to try to help you all avoid some of the pitfalls that we fell into getting started in 3D. The link to this presentation is at the bottom of the slides, and at the very end there's a link to our GitHub and links to more specific code examples that are relevant to some of the slides. Please steal our code. Also, the images in the right columns should all have a link to the actual 3D object in their citation. I highly encourage you to start playing with these and totally not hear another word that I say. So here are a few of the things that I wish I had known when starting out. I'm planning to talk about the technologies and processes that are used to take the source images and create the actual models. I'm planning on talking about how you can very easily embed them in your web pages. And I'm going to talk about these things in the context of 3 collections from our online repository. Whoops. So getting started with capturing images and using them to create models. The first tech to cover is photogrammetry. It's extremely accessible. You can take the images you need with your phone. A DSLR is even better, even an old one. There's also several very good quality reconstruction software packages that are either free to use or open source. So I figured I should at least try this out. I usually just write the JS. So I created my very first model using my grandmother's antique toy dog. And I just used my phone in my super creepy dark basement. And I really don't think it turned out too bad. There's a link down there at the bottom of the page. So that's what photogrammetry is. My experience with 3D is almost completely front-end JS, so I'm really not qualified to talk about how it works. So how does it work? Photogrammetry uses a collection of still 2D images that are collected in orbits. The camera rotates around the object, taking overlapping images. Then reconstruction software tries to identify the same points in multiple images, and it uses triangulation to try to place those points in 3D space so that it can reconstruct the object. Here's some suggestions for capturing effective images. This isn't really my thing. You can read it at your leisure, but I'm kind of going to skip it because I've got a lot to cover. So after you have a good set of images, they'll need to be run through reconstruction software. And if given good data, these software packages can do an amazing job. But still, it's a given that some editing will need to be done in modeling software. Now, this is different than the aforementioned reconstruction software, although, again, there are several very good options here, and Blender is free and open source. Now, investing time up front editing and modeling software will save time and really improve quality when you're actually rendering these models in the browser. And here again, consistency is key. I think this part is really important. If the people doing the editing in the modeling software are not the same people doing the front end dev for the web viewer, then the stuff on the next slide really needs to be a discussion, and you should probably come to agreements on these things. You'll need to think about the location and position of your models. It's important to decide where the models will be placed relative to the horizontal plane. Some people center the model about the origin. Some people put it just on top of the horizontal plane. But whatever you decide, you just need to stick to it for consistency. Models do need to be centered around the vertical axis if you plan to rotate them, or they'll get all wonky and wobbly when they rotate. Also, you'll need to think about your model scale. Models that are scaled according to their actual physical size can actually be really tricky to work with on the web. If it's realistic, it would probably be worth it to export web-specific derivatives that are scaled consistently with each other. For rotation, you really want to think about how your model should look when it first loads in the browser, and then try to export it from the modeling software in that configuration. Now, it's really important that you make sure that the coordinate system in your modeling software matches that of your 3D web viewer, because they're not always the same. Some software has Z pointing up, some has Y pointing up, and that can really mess you up if you don't realize that's what's happening. Okay, so that's editing the materials, like pre-processing, now handing them off to go to the browser. For web-based 3D browsers, again, there's lots of choices, and this time they're basically all free. Babylon and Three.js are two of the most popular. Our team is currently using Babylon, but I actually got started out using X3DOM. Oops. Click the link. Okay. We first decided to try a collection when we heard about some models that had been made from Virginia Tech's entomology collection, and we were pointed in the direction of X3DOM to try to make it work. X3DOM allows you to define your, here we are. Allows you to define your 3D content declaratively using HTML5 components. It basically feels a lot like writing React. It's a really easy way to kind of dip your toes into the water with this stuff. There is markup for a full valid HTML document that renders a 3D object with X3DOM that fits on the next slide. You can see there's a pair of X3D tags with box tags nested inside that render a cube. You can just replace those box tags with similar tags that contain a link to your model file, and you're kind of all set. There's a link up at the top where you can see it running and interact with the cube. And our entomology collection is still up and running on X3DOM. The next collection we were asked to do is the most important collection that I've ever worked on. It's titled Eggs Painted in Remembrance of the April 16th, 2007 Virginia Tech shootings. An artist named Carol Davis painted 32 decorative eggs, one for each of the victims. It's a heavy collection, and I was actually pretty honored that the library was going to try to let us make this at all. So around this time, we started experimenting with some 3D viewers that are more fully featured, and we hoped this would give us the tools we needed to represent this material in the way that we really wanted to. We ended up working in Babylon JS, which does require some scripting knowledges, but it gives you a crazy amount of control over your scenes. So now that tools are out of the way, I want to talk about thinking in 3D conceptually. It's definitely different than traditional web development. And I've been doing web dev for a really long time, and I'm used to positioning DOM elements all over the place with CSS, but you can't think that way in 3D. And it took me way too long to figure that out. 3D relies on the concept of a camera, and for a library use case, it's almost always better to position and move the camera than to position the model like you would with CSS. And it's also really important to consider things like lighting and shadows for your 3D scene. So that's basically what I have, and at what I considered enough to get started, which was the talk. However, I have a whole bunch more material here in this slideshow, and you all are welcome to check it out at your leisure if you're interested. And I need to go to my actual thank you page at the very end. Give me just 1 second. All right. Thank you very, very much for your time. None of this would have been possible without the talent and hard work of Eva Desa. Thanks to Code4Lib for this opportunity. Thanks to everyone at Virginia Tech Libraries for letting me stick around for so long. And thanks to my mom and dad for giving me all of these opportunities to do all these crazy things in life like this. It means the world. Thanks, y'all. Take it easy.
And thank you for keeping to time. You'll be able to answer questions in the Slack and ask and answer questions in the Slack. I really like a talk that makes me think of things in a little bit of a different viewpoint. Okay, the next talk is Supporting the Hidden Work, OSS Projects for Inventory and Weeding by Maccabee Levine. And so we just need to get rid of the Zoom. Bye.
Bye, thanks.
There we go.
Yeah.
What? I thought I did. There we go. Okay, so your talk is down here somewhere?
Yep. It's already open.
Oh, so it's which one is PowerPoint?
Second from the right,
Oh, yeah.
in the middle.
Super.
There we go. I'm just gotta find the project button in here. How do I start the show? It's up here, right? There we go. Did that work? All right.
Thank you.
Hello, I'm Maccabee. I'm at Lehigh University, and I'm going to be talking about supporting the hidden work, some open source projects we built for inventory and weeding projects. So this is Linderman Library at Lehigh. It's one of our 2 libraries. It's our arts and humanities collection library. As you can see, it's a really, really beautiful building. These are 3 photos I took from our library's marketing photo store out of dozens of photos of Linderman there. But you know what there were no photos of in the marketing store of Linderman? What in fact makes up most of our beautiful library? Yeah, our stacks, right? I had to take this photo. It was shall I say, a hidden part of the library according to marketing. And I wonder if for our community and for library devs in general, it's a hidden part of some of the work that we do. So my question for today is, are stacks a solved problem as far as technology goes? Does your library have a large physical collection? We have about 600,000 odd items across our 2 libraries. And if so, my guess is that that scale creates challenges. For us, it creates challenges with finding missing items for patrons. It creates challenges with shifting things around to make room for new things, with identifying damaged items that may be in the stacks in various places, and even just knowing what's even on the shelf in general. And a meta question here is, the people that do that work, given the scale of it, are they respected and acknowledged for the scope of that challenge, given how many items are concerned there? And are we as technologists, as we think about digital libraries, remembering that there may be a role in offering help with the physical collection as well? The sort of TLDR of this presentation today is, when you're done with the conference, have a conversation with the folks at your library who manage stacks and see, is it a solved problem on your campus? But since I'm guessing those folks are not in the room with you right now, I'm going to try to bring them to you here today. So please meet Meredith Constable. She's the library coordinator at Linderman Library, the Arts and Humanities library that I just showed you. And Meredith says, your average person doesn't really know or realize all the work that goes into maintaining a physical collection. People think it's very static, books on the shelf, that checkout and return is just the tip of the iceberg. The other work is so necessary to the health of the library. There's a known phrase, the library is the heart of the university. She said, I think it's a good analogy for some of the work we've been doing in stacks management, where we're kind of the steady, constant thing, but when you really look at it, there's a lot more happening than you realize. So what I'm talking about here today is 2 projects that we worked on collaboratively to address our stacks. One for weeding, one for doing a full inventory of the collection. Sorry, NVIDIA, but neither of these projects involves AI at all. Neither is a particularly innovative tech stack. That's not the point. They're both practical solutions to support our colleagues who are doing that stacks management work, and they're both available for other folks to use as helpful. So first I'm going to talk about a project we did for weeding called Project Pluck by our humanities librarian, because it takes pluck to be brave enough to weed your collection, and you are plucking things. Credit Heather Semino. Please meet Ricky. Ricky is the library coordinator of our other library, Fairchild Martindale, where we have our science and engineering and business and so forth collection. So why did we care about doing weeding? Ricky explains, you might go up there and you'd see there's a ton of room for growth, but you might go into other areas and see it's so packed there's nowhere to go with these items. Part of that's because some areas of the collection might be a hot and growing subject matter, so it's going to expand more rapidly. Shelving can be really difficult when it's a really packed area. Sometimes there might be local space available a few shelves down and we can do a micro shift and make that additional space. I learned what a micro shift is. Anyone else had not known that? Okay, there we go. Other times there might not be space for another 3 columns over. So the local solution we built to help with weeding is an app called Project Pluck. As you can see, it's a Google Sheets-based application that loads data into a spreadsheet from a particular location as identified by our LSP, and then helps selectors make decisions about what to do with that collection. You can see it pulls in most of its data from our LSP, including things, as you can imagine, that would help decide whether to weed or not weed, like how old is it, how much has it circulated, do we have retention agreements for it, is it by a faculty author, that sort of thing, as well as from OCLC, holdings counts, and some data from Hathi. And then the selector simply uses the spreadsheet to indicate what they should do with each individual item, perhaps retain it, perhaps move it to special collections, or perhaps withdraw it, and optionally a note explaining it further, like why the particular decision was made for future reference. And of course, we write those decisions back into Folio and do various automated post-processing, such as withdrawing the item and its various instance hierarchies within Folio, if that was the decision. So that's how it works. The tech is, as you saw, uses a bunch of APIs, including Google Sheets. Google Sheets runs via Google Apps Scripts environment, which has its own cloud-hosted IDE. It's not great, and if you're doing any work with Google Apps Script, I highly recommend looking at Clasp. It's a utility to sync code that you can write locally with your preferred IDE and just push it up to the cloud every time you save a file, so it does save time. That being said, don't use AppScript for a project like this. It's great for small projects, and we use it for small reporting tools, but one of its features is that it ends every 6 minutes. It just kills its own job, and that's intentional. So we had to do a lot of monitoring Mojo to keep it running. LDP, if we had MetaDB available at the time, that would have been a much better tool. I'll get to that later. And weeding is just less productive without a current inventory. But why did we do this? Did it actually work for the goal? Meredith explains, I can't imagine how long it would have taken without the tool we developed to do this. Last year, when we did a whole weeding and organizing and moving of our oversized collection, which is only like 1,200 or so physical books in our building, and it still took a couple of months just to do that. And that was with the spreadsheet. If we had to spend our own time researching each of these items individually, it would have taken forever. So that's one project. The second project I'm going to talk about is called Folio Offline Shelf Reading. It's a tool for inventory. As I explained already, we needed to do inventory before we could do accurate weeding, but why else did we want to engage in this? As Ricky explains, there might be times when we would send students up just to do shelf reading, and we would have them make sure things were in order, like if we came across an area that was just like a rat's nest, very mixed up. Someone might come to the desk, I'm looking for this, and it's not there. Or you might get an email. I wouldn't say it's a 50-50 shot of whether or not it's going to be up there, but I felt like there was a little less confidence in our holdings. Right? This isn't the feeling that we want our circulation staff to have to deal with when someone comes to the desk. Our solution for this is a web app called Folio Offline Shelf Reading. Similarly, it will load a list of items. The idea is a student will roll a cart with a laptop and a barcode scanner into the stacks, and they'll scan the first and last barcodes in whatever range they want to scan, maybe a shelf, maybe a bunch of shelves. And then they will go into the stacks. Maybe they don't have a good Wi-Fi connection there, that's fine. And they'll individually scan each item in order, one by one. As they do that, it will mark present locally in the browser the things that they've found, and we'll keep track of the ones they didn't. There's also a separate set of barcodes for damage. If a book has mold or needs a new spine label, there's a way they can indicate that. So as they go book by book, they scan them all. Then they can move back somewhere with a good Wi-Fi connection, hit another button, and it all gets saved back to Folio, both things that were present and things that were missing, as well as those condition notes. Statistical codes being used for record keeping, and item notes being used for the details of whatever was scanned. Tech notes, this use MetaDB, which is a great reporting tool. It essentially gives you a SQL view that's easily accessible for folio data, which depending on your hosting provider, you probably can't access directly. The loading of those items was far faster than the previous tool that I mentioned. The web app is a basic Python and Flask tool. One problem we ran into with this project was that it relies on shelving order, of course, to work. Folio, like so many of other tools, uses Mark4J, and it has a tool to define a shelf key, which turns into shelving order, but the rules of Dewey cutters and parsing those don't quite match what we have in use at Lehigh, so shelving order didn't quite work, and we had to build some special tooling for that as well. Happy to talk about that if there's any questions. But again, the point is not the tool, the point is what the impact was. Meredith shared one book being misshelved in the wrong area effectively makes it gone forever until you do an inventory and find it. We've been finding these books. I'll be like, oh, this book was marked missing 3 years ago. We actually found something recently that was from another library that we have like for decades that was in our collection for some reason. Ricky says, the work itself is invisible, but I think the impact that it has, whether people realize it or not, is front and center when you're searching the library catalog. People come to the library expecting to find the books that they want, and if we don't have what we say we have, then we're clowns, you know? Adding that integrity to our holdings is paramount. We want to have what we say we have. There's no way we could have done an inventory project to this scale without that tool. So just a few final thoughts. Obviously, this is a highly collaborative project. I don't work in lending services. I wouldn't know the first thing about these processes or whether they were working well or whether they weren't working well. Again, I encourage you to talk to your local people about them and see if there's anything that can be done to help. But the key takeaway here is meat space still matters. I say this as a vegetarian for what it's worth. Meat space still matters. What can we do to support this, what I think is hidden work to many of us in stacks management and then other physical space needs in our buildings? Let's support our colleagues who are working in hidden ways in those areas across our libraries. And let's share more in this community and as open source software. I have screenshots here of a Code4Lib journal article from a European library that was working on a weeding project a while back. And one of the first talks I ever saw at Code4Lib from NCSU way back talking about a tablet app they developed for space assessment. The point here just being that our community has a history of talking about how we can improve the physical spaces for our communities. So let's keep that up. And thank you very much. That's it.
If anyone has a question for Maccabee about meat space or anything, oh, we have a question. Yay. Mic minder? You want my mic? Here.
The run for the mic. Who will win? Which mic will
Take hers.
Could you talk a little bit more about sort of your information process for speaking with individuals at your library to like figure out the best ways to solve their problems with technology?
Sure. So I wish I could say that it was as proactive. You know, a lot of it has been they came to me with this request and learning about things afterwards. But we did have a previous tool that was built by an excellent developer who used to work at Lehigh. And it was being used, but it had roadblocks that, of course, in any project you build, you don't always know those roadblocks. And so I did shadow Ricky as he was doing weeding in our stacks and just saw using that tool because it was Google Sheets based, it required a network connection. Every time you would click something, it could take up to 20 seconds to mark that in folio. It just wasn't productive, and so it just wasn't a good process. And so ultimately, it was a lot of conversations, sitting down with people actually doing the work. What do you need to do this? And then not just the work of, like there's multi-step processes. Even with inventory, if we discover something's missing or needs to be reshelved or needs to be condition fixed, there's work after that. So how can we design the process to work best for those stages that come after? It's still a work in progress, though. I'm sure a version 2 will improve.
One more question if you want. Well, let's thank Maccabee and all the other speakers who kept to time. All right, now is the time we've been waiting for, except you have to wait. Oh, it's right there. Excellent, excellent, excellent. I can actually read it from here. Group number. All right, there's something I have to click on, so that's why I really have to get this. Okay, right. So breakout sessions, 2:30 to 3:45. We have 7 breakout sessions, and there are going to be some great ones. This will be followed by a coffee break, and the poster sessions will be up. We're going to meet back here at 4:30 p.m. for our final block of talks for today, at least. And then lightning talks for tomorrow morning are available by the registration desk. Breakout session sign up for tomorrow at 11:05 is also available in the same area. Poster sessions will begin immediately after the breakouts from 3:45 to 4:30 out in the ballroom foyer. Poster presenters, be sure to make yourself available at your poster to take questions. Okay, poster presenters, be sure to collect your poster before you leave today, if you want them. They will not be kept overnight. Be sure to learn about our exhibitors if you haven't already. They're set up in the ballroom foyer with posters and coffee break. Those exhibitors are Hosting Solutions and Library Consulting, Discovery Garden, For Science, and Kenius. Okay, breakouts will begin now. The sign-up sheet is still posted by the registration desk. We have listed locations for each of the sessions on the sign-up sheet and on the conference site. I'm going to, hopefully this will have the map. Yes. All right. Ballroom A1 is archives space with Deus? Des? Devs. Oh, spelled wrong. With Dios the devs. All right. Ballroom A2, local and open source discovery systems. Ballroom E2, alt text with or without AI. That's where I'm going to be. Ballroom E2, Gen AI and LLM. Main ballroom, that's this room. In the front, digitization, workflows, etc. with Anne-Marie Mesco. The main ballroom, left side, that is that side. That will be tech lead safe space with Andromeda Yelton. And finally, on the right side over there, we will have Islandora. Did I get the left and right? Yeah, right? Yeah, okay. So, go for it. Go and break out now.